Hello and welcome to BlastOne. This afternoon we're talking about compressors. Compressors come in many forms, shapes and sizes. It's important to recognise what your requirement is in relation to the amount of air that you're going to compress to do the job adequately. This afternoon we're going to be talking about a 400 CFM compressor, and we're just going to run through the general maintenance requirements in relation to a compressor on site. So the first thing we're going to do is look at the environment. What effects are this compressor going to have on the environment? Is it going to produce too much exhaust in relation to where I'm working? Is the environment level? So the most important aspect of these particular units is they must be set on level ground. So with this particular jockey wheel, I'll ensure that the compressor is brought to a level status. Also too, it's important to install the park brake. Compressors also come with wedges. Wedges are sat behind or in front of the wheel, so fore and aft of the wheel, to ensure that the unit cannot roll or move whilst raising or lowering the jockey wheel, to ensure that the unit is level. So as far as the housing of the compressor is concerned, I'd make sure that the compressor is not set on the downside of the wind for spray painting, primarily because the overspray will end up all over the unit and you'll either have to clean it or the person that you've hired the machine off will be very unhappy with you. So ensure that the environment that you've installed the compressor in is appropriate in relation to your requirements. So with any compressor we have several outlets. You'll see that these are inch mince-up couplings and a 2-inch mince-up coupling. All of them have valve handles on them. So before starting the machine, make sure they're all off. Primarily because the operation of the machine is driven from here, so you'll be standing there. So ultimately you won't start the machine with these valves open. The other aspect of it too is that those valves need to be closed because the compressor needs the capacity to read the pressure feedback to start and appropriate the air in conjunction with its normal operation procedure. Most compressors nowadays have a computerised system in there. It makes it easier for the operator. Also too, as far as that is concerned, the operational panel, there is always a start and stop procedure and a warning in relation to what can hurt you in regard to this particular machine. Well, it turns and burns, so there's all aspects of it that you have to be conscious of. One important requirement with these units is they all have opening doors, lift up doors, to give you access to either side of the compressor, battery, fuel and so forth. It's important to ensure that during operation all these doors are closed because the compressor draws the air in the appropriate ducting rather than just open air, so it needs the fan to have the external air or an environment drawn through the machine to cool it in an appropriate manner. So it's designed as such, not to have the doors open. Also too, if you leave the doors open, you leave it exposed to the elements, and if you're grit blasting, the grit and dust will end up inside the machine, which is detrimental to its long-term operational qualities. So as far as operating the machine is concerned, yes, there is the fundamental requirements to start, check engine oil, coolant, fuel, compressor oil, all of those items. So just to quickly run through them for you, before I start anything, I ensure that the machine is level, the handbrake is engaged, chains and so forth are up out of the way so no one can trip on them. The machine does have a fire extinguisher, which is powder, which is indicative to the type of fire that this machine could have. So if you do all the appropriate checks, you eliminate such possibilities of fires, damage, danger and so forth. So to check the oil on the machine and to check the battery and functionality, you'll need to open the appropriate doors to give you access to those particular items. With a diesel engine, which most of these are, you'll very rarely find a petrol-driven one. Because they're diesel, there's only two things that will stop a diesel engine, which is fuel and air. So if it doesn't have fuel, it won't go. If it doesn't have air, it won't go. So where does the air come from? It's filtered through and sent into the naturally aspirated, or in some instances they have a blower on them, so it needs a lot of air to actually keep the engine running to its optimum and to reach the revs required to maintain functionality of the compressor, which is the part that you're concerned with. So the first thing I do, if the compressor's been sitting around for some time, is I'll access this particular door here, which will give me access to the battery. So the battery normally has an isolation switch with it. So what an isolator does, it interrupts a current. So with any electrical system, it has a flow through or a current system that has to be followed. So where it goes in, it must return. So to interrupt that return of electrical current, they'll put an isolation switch in there. So the isolation switch is designed to make this control panel inoperable when that's been initiated. So the first thing we'll do is we'll check to make sure that we have the isolation switch engaged to give us current. And if the compressor's been sitting for some time, it's probably a good idea to check that the battery has enough charge to start the machine. For that requirement, we have a circuit tester or an amp gauge to see if we do have adequate amperage and voltage to start this particular machine. So with that in mind, what we'll do is we'll put a probe on the positive side and the negative side of the battery, and we'll check to ensure that we have adequate current to do the job. So in this case, what we're looking for is 12 volts.